sorry, cut in the middle of the announcements there. I forgot to hit record, so now we are recording. So anyways, the last two things that you see on the announcements: extra Zoom session. Last Friday it was at 9 a.m. This Friday is going to be at 11 a.m. Reason for that is staff meeting and department meetings, different things I have to do with other teachers. So if you have questions on Friday's Zoom session, 11 a.m., even if you don't have questions, you just want to come in, hang out, chop it up, I'd be happy to do so. I'm going to be on here. And last but not least, fourth quarter progress report grades due Monday by noon. Obviously, the craziest part, other than us being stuck at home and the weird way of learning, is this whole grading system. So really, as we've gone to remote learning, how things are being graded, how often things are being graded, how our grades are going to be affected, that's still kind of all up in the air. I know that we're going to get some more information on that, both as teachers and as students soon. But as of now, we have fourth quarter progress report grades due by noon on Monday. So try to get any homework or ed puzzles in by then. Okay. Grades have been pretty good. A lot of participation has been really solid. So hopefully grades have been going up because of that. I have also reclassified. If you've been looking at your Infinite Campus, I've been creating new classifications of grades. So basically, let's kind of go over that actually real quick. Let's do a new page. I kind of want to give you a heads up as to like what's been going on in the grade book, okay? Originally, pretty basic breakdown. The semester was set up to be like this. We had homework assignments, we had quizzes, we had tests, and then we had a final. All right, the homework was 10% of our grade. Sorry. Quiz was 10%, tests were 60%, the heavy hitter, and then the final was 20%. So this was the original breakdown of grades. Since we've moved to remote, I have adjusted the actual breakdown, and I did this last Friday. And great question I just received from one of our students. Quarter 4 progress report grades are not final grades. No, just that kind of letting you know where you're at as of now for the semester. It will be the last reporting of the grade before your final grade though. So that's a fantastic question. Just a progress grade, not final. It can be adjusted as you continue to work throughout the rest of the semester. So as I adjusted the breakdown on Friday, here's what happened. I basically took off the final. Okay. And what I did with that 20%, because you can see here, now we only have 80% available. What I did is I transitioned that final 20% into 2 new categories. Basically, remote homework, remote assignments, everything that we've done since we've gone to online is 10% of your grade, effectively 1 whole letter grade, okay? And remote assessments, okay, which is like a fancy way of saying anything that could be assessing or testing what you do or do not know on a macro level, okay? So basically what I've done is I've now doubled down or doubled up the importance of doing homework. Keep in mind that I've been leaving a lot of leeway in terms of when you turn in homework. So if you're late, no stress, email me, let me know, get them in, we'll get you that 10%, okay? So long story short, took off the final 20% and then dropped it into 2 new categories. And I just want to mention that anything that we do moving forward, like these projects that you might have seen on our remote learning agenda, like down here towards the bottom, the logs project and or the portfolio project, that is going to fall into the remote assessment category, okay? So just a heads up on that. I changed the style of grading up a little bit to hopefully make it more effective given the situation, to not penalize at all any kind of missing homework, but also try to build up grades as much as I can, okay? So if you have any questions on that, let me know right now, or as always, fill out the RLQ or email me and I'll be happy to go into more in-depth information on that front. All right, cool. So that's basically the accumulation or completion of our announcements there. All right, today then we're going to move into lessons 2 and 3, finishing up lesson 2, degrees in a circle, and then moving into what's called the radians of a circle. And hopefully we can use our previous knowledge of circles that we've gained from elementary level math, diameters, radius, etc., circumference, coupled with our knowledge of circles as we saw last year in geometry when we were doing all that tangent, secant, chord, all that good stuff, and now kind of combining into one thing here in our circular understanding of trigonometry. So the very first thing that I want to do is start off with the vocab on pages 3, 4, and 5. Keep in mind, y'all don't have the text in front of you, but I have uploaded it. So if you have a virtual copy of the text, feel free to check it out right now because that's what we're trending towards. All right. Here we go. Okay, vocab on pages 3, 4, and 5 look a little something like this. As we were moving through lesson 2 last week, we saw varying forms of degrees and circular motion, kind of realizing that a circle is just these transitional angles that we've seen before: acute, right, obtuse, and straight. And if we just kept trending this ending side of the angle, eventually an angle could theoretically make a full circle, full revolution, and that's what the unit circle is going to be. So kind of just quickly defining some of the main words. The ones that aren't highlighted here on the screen are ones that you probably have run across ad nauseum, meaning over and over again in your math class. So I don't really want to spend too much time defining what a degree is or what something that's moving counterclockwise is doing or what a rotation or a radius is. But instead, just kind of looking at these things here. In geometry, you were forced to learn what a ray is. An array is basically just if you have a starting point like the sun and it goes on forever, like a sun ray goes from obviously the energy source sun out to us, all those gamma radiation rays. That's the same thing in math. Effectively, when we have an angle, it's made up of one ray, two rays, and that thing that we call vertex, that starting point. So the terminal ray, on the other hand, kind of builds off our knowledge of what the word terminal means, or termination. So in a variety of senses here, different contexts, the terminal in an airport is basically the last place that you go before you get on or off the airport, on or off the plane rather. So it's the ending spot in the airport. Just recently, actually, coincidentally watched the movie Terminator. The Terminator, what that person does is he ends, Arnold Schwarzenegger ends or kills things. So effectively, when things are terminate or terminal, it means the ending ray. It's where the angle stops. And conversely, initial ray is where it starts. So if I was to just draw a quick angle here, boom, little cute angle, we could call this our initial ray down low. And how the angle is trending from start to finish describes where its terminal side is. Again, only talking about these words just for sake of understanding what I'm discussing when I go through the unit circle. All right, terminal ray and initial ray start. Here we go. Big three for today are reference angle, coterminal angle, and radian. A reference angle is basically like when we were talking about those right triangles. And I said, all right, we have a 37-degree angle here. We're looking for the hypotenuse, and we know this is 12. I was referring to this angle theta 37 as our reference point because that's where we're looking from. So when we're working with a circle, we're always trying to make easier, smaller angles, angles that are more easy for us to understand, but we're more comfortable with. And that's kind of what we're going to refer to as a reference angle. It always connects to the x-axis. Coterminal, we already know terminal means end. Co means together, like community, a bunch of people that live together. To coexist means to be around each other. To cooperate means to work together. So coterminal angles end at the same exact location. They have the same terminal sides. And last but not least, for some of you that have completed the Edpuzzle right off the bat, what we're going to be trending towards the last part of our class today is a radian. The word radian looks a lot like one of our other concepts, major descriptors of a circle, a radius. And there is no coincidence in that. That's for a reason. A radian basically describes not how the angle is moving as a circle, but rather the arc measure. So what I mean by that is if we have a circle Whoa, that was really bad. Sorry about that. If we have a circle, much better. And we basically accept the fact that this circle has a center and a radius. Well, what this radius is right here is basically a starting side to an angle. And as this angle starts to move up, the blue is the terminal side. As it moves up more, the angle measure gets more and more increasing in value. And then it keeps moving, and eventually we see that this angle could keep going over and over again and just keep revolving on it like a wheel. But effectively, what we've just described here is, in terms of an angle, in this one, a 180-degree angle or a flat angle. Degrees measure displacement via movement like such, whereas a radian talks about movement or distance around the arc. So degree talks about how an angle kind of looks like a slice of a pizza. The radian is effectively how much crust you have on that pizza, how far around the circle you've gone with that degree movement. And that's what a radian is. So effectively, we can understand radians with easy conversions from our knowledge of probably 6th grade level math, if my memory serves, and that's with the idea of a circumference. So a circumference of a circle, as we learned, oh, never mind, I don't have to go too far, it's right here. The circumference is 2 times pi times radius. Every single circle that we deal with in this unit is going to have a radius of 1. So really, the circumference of a unit circle is always just going to be 2 times pi. So as we transcend or transition better into understanding radians, we're going to be using this idea of circumferences and our knowledge of how a radii or a radius can affect a circumference. All right, that's a lot of vocab right off the jump. So again, just kind of prepping our minds for these words moving forward. All right, so let's pick up where we left off on Thursday. And on Thursday, we started to kind of see this idea of circle being a bunch of different angles, just basically depending on where you stop, a circle is just an angle, a revolving angle, hands of a clock. All right. So then what we're going to do now is really quickly move through the rest of lesson 2, and this is going to be basically matching at this point, because all we're doing here on the next page, which is on page 30, by the way, this was on page 29, what we did last week, creating that circular angle through the knowledge of reference angles as we'll learn them, is now basically on page 30. We're just going to be basically matching this picture, not that picture of me, but this picture to the problems like number 5. So on number 5, it says, all right, on this circle, don't use a protractor. Tell me the measure of this angle. And we're going to do this real quick. Okay. So I know for one thing that it's less than a right angle because a right angle is the red angle. And so I know the angle degree here, if I wanted to call this angle theta, I know it's going to be less than 90 degrees, but I don't know exactly what it's equal to right now. So what we're going to do is we're going to reference the page right above and see which one of these angles that were less than 90 matches number 5, and inherently, oh, boom, it's 60 right there. So on number 5, the angle value of this one is theta. Cool. And that's 60. Sorry, I said theta, but 60. Okay, number 9, cruising. Let's see if I can make this transition a little bit easier so I don't have to scroll up and down. Awesome. So on number 9, the angle that we're looking at is basically a right angle going down and to the left, moving counterclockwise. What angle does that match? Not letting me zoom in. Thank you. Cool. Boom. That's 270 right there. Effectively, what number 9 is saying is if we have this angle here, let me do this in a different color, blue. We could think about it in 2 different ways. Either it's moving 90 degrees in the opposite direction, or effectively, if you think about it like this, 360 minus 90, or it's moving 90, 90, 90 that way, which would be 90 times 3. Either way that we get it, the angle represented by number 9 is not 207, but rather 270. So effectively what we're saying on number 9 is just through the use of that circle that we just created, this circular movement, that theta is 270. All right. Number 12, where's a 30-degree angle? Here we go. 30-degree angle's obviously got to be somewhere within this range because it's less than 90 degrees. I'm going to eliminate one of them. I'm going to say that one's not 30 degrees because that's halfway between 0 and 90, so that's got to be 45. So basically what we've just kind of come to the conclusion is if this one's 45, well then the 30-degree angle has to be less than it. And that's our little 30-degree slice right there. Or as we saw on our unit circle that we just created, oh, it's that first angle from 0 trending upwards, little smallest acute angle of our reference angles, our major angles. And number 13, degree 210. Unfortunately, I can't really have y'all answer this one because it's really cryptic in the answer, but here's how we can do so. Ready? I know for a fact that this is a 90-degree angle. 210 is way bigger than that, so I got to keep going. I know for a fact that this is a 180-degree angle, a flat angle halfway around the circle, 180 degrees. So basically, I need to keep going. Now the question is, how much farther do I have to keep going? And here's how we can figure it out. Well, we take 210, we subtract the distance we've already elapsed, 180, and we figure out, oh, okay, we need another 30 degrees, which is a fancy way in trigonometry speak of saying, all right, let's make theta 30 degrees. So from our starting point, or our point right now of 180 degrees, we want to go 30 more to get to 210. So we realized from our last example that this little piece of the puzzle right there was a 30-degree angle. So in geometry, we learned something called vertical angles, which is angles across from one another. We use this often with chords. And boom, look at this little angle right there. That is 100% a vertical across from it, from that 30-degree slice, which means that this right here is actually just a 30-degree movement. So if we know this is 180, let me actually do this in a different color. If we know this movement from start to the flat line was 180, and then we are adding on that 30 degrees, well then what that really means is that our 210-degree angle is going to be this mondo angle here, where we went from 180 degrees plus 30 more degrees. Boom, there's our 210-degree angle. It looks a little something like this without all the other color involved. Cool. So how we did that right there, by the way, was through the use of what we defined as a reference angle. And what I mean by that is, effectively, we used a really, really easy angle, 180. And then we figured out that we only needed to go 30 more degrees. So we referenced our 180-degree flat line and just said, all right, let's just make a little small acute angle that we're super comfortable working with and make 210 as a combination of a flat line plus 30 degrees movement. All right, that's a lot of information straight from the jump on page 30. But before I move forward, does anyone have any questions? Going once, going twice. Let them fly on the chat box if you do. All right, cool. Last things I want to talk about in lesson 2 are the idea of actually applying coterminal angles. Remember, we mentioned coterminal means co meaning together. Oh, forgot my pen was so big there still. Co meaning together or the same. Terminal meaning ending. So coterminal angles end at the same exact point. Therefore, in number 18, it says if we had a 60-degree angle, initial side here, boom. Ending side, terminal side there, let's call that 60 degrees right here. Okay, very, very rough 60-degree angle. I obviously didn't use a protractor or a circle to measure that, just really kind of drawing on our knowledge of what a general 60-degree angle looks like. If we have a 60-degree angle, one coterminal to it is negative 300 degrees. They want to name 2 other angles, and here's why one coterminal is negative 300. We'll cruise back up to page 29 real fast. So here's our 60-degree angle right here. Ready? Boom. 60 degrees right there. Not that good of a trace. Sorry about that. All right. The reason why they say 300 degrees or negative 300 degrees is coterminal is because if it's going negative, it's moving clockwise. So it's going back that way. And 360 minus 300 is 60. Now they want to know if we can name any other angles. And here's the final kind of jump of this whole entire lesson, is that angles don't stop at a circle. I'm sure if any of you ever as a kid twirled around in a circle, you realize that you don't just stop when you make one full revolution. You could theoretically spiral as much as you want. So all we have to do to find terminal angles or coterminal angles is basically make a revolution. And that would be done by adding or subtracting multiples of 360. So another angle that is coterminal to 60 would be 60 degrees plus a full revolution, a full circle, which is equal to 360. Another one would be just taking that same value, 420, and doing another spin or cycle on it, adding 360 to it, right on. So to find coterminal angles, basically angles that stop in the same spot, you're just making rotations. You're just going around in a merry-go-round. So you're basically just doing plus or minus 360 continuously there. All right, to finish off class today, we are going to delve into that idea of a radian, what we started off with defining as a vocab word, what some of y'all have done as an ed puzzle. If you haven't, check it out. And let's get now to lesson 3, which is where we're going to kind of very quickly and efficiently describe maybe the first few points on this very same unit circle. Notice consistency in layout between the circles. Now we're not going to define it in degrees as we did on the page that you see in front of you, but here on this page, and this page is page 41, we're going to start to jump into the idea of radians. And if you didn't catch it in the beginning, a radian looks a lot like the word radius, and there's a reason for that. And it's because a radian is just a portion of the circumference, which I think is a nice way of kind of using English words combined with math words to describe it. It could be the full circumference, by the way, but effectively in a more direct geometrical way of describing it, a radian is just an arc measure. Okay. So theoretically speaking, that's a radian. That's a radian. And all a radian is basically doing is saying, hey, if you started here and you walked like around a circular lake or a circular, I don't know, fountain at a park, the radian measure would be saying, how far did you walk? Kind of go back to that analogy of the pizza metaphor there, or the pizza idea. How much crust, how many inches of crust do you have on that pizza, so to speak? Okay, so radian time. This entire circle, as we'll continue to learn, and we'll learn more about it directly next week, is called a unit circle. And it's called a unit circle because the radius, not radian, but radius, is 1 unit. 1 foot, 1 inch, 1 yard, it doesn't matter. It's our favorite number, it's 1. And the reason why that's super efficient is because we know, sorry about that, that's the circumference, or effectively a bunch of radians, a bunch of distances around the circle. We know that the circumference of a circle is equal to 2 constants, the number 2, times the number pi, about 3.14, times whatever that radian is, or radius is, excuse me, not radian, radius. So therefore, the circumference of a unit circle is really just 2 times pi, and if it's a unit circle, our radius is 1, which is awesome because anything times 1 is always equal to itself. So what we're now seeing as we work through creating this unit circle is that the radius is 1, the circumference, that entire distance around the circle, is 2 times pi, or as the vocab defined it, approximately 6.28. So the last thing that we're going to do for today is we're going to start on numbers 1 and 2, or really probably just number 1 here, to kind of define what the point halfway around the circle is. The point all the way around the circle is 2 pi. Okay, that's where we got that 2 pi from labeled for us. But the point halfway around the circle is just if you made a 180-degree rotation. We described this last time on the last page as 180. Now we're going to describe it in terms of radians. Keep in mind that the entire circle is 2 pi. So if we wanted to figure out basically what the distance is here, we would take the entire circle, which was 2 pi, and we say, all right, we only went halfway, so we would divide it by 2. 2 pi divided by 2 is a nice easy fraction problem because guess what? Numerator and denominator have common factors. Divide 2 by both. Boom. We now know exactly what the distance halfway around the circle is. I'm just going to use the same color here, pi units. Okay. So in terms of radians, the distance halfway around the circle is 3.14. 1 radian the distance halfway around the circle, 180 degrees, is equal to 3.14 radians. All right. Next thing, last thing, we want to talk about the distance halfway there. So a quarter way around the circle. We could take the same logic, by the way, and we'd say, all right, a quarter way around the circle, which we know to be 90 degrees, is also the same thing as the circumference, 2 pi, cut in fourths, cut into quarters. We simplify. 2 and 4 have a common factor of 2, and that just leaves us with 1 times pi, or 1 pi, or pi, divided by 2, and boom, there's our radian. It also holds true if you think about it as follows. That blue distance around the circle here is really just half of the semicircle. So therefore, it makes sense to think that if this whole green distance is pi, well then this one is just pi cut in half, pi divided by 2. That's the relationship between these two. And then if we use our knowledge, then all right, if 90 degrees is pi over 2, well then really, to get to this 270-degree angle, little small zero there, sorry about that. All that we're going to do is we're going to say, all right, we know that this is pi over 2 radians, that distance, that piece of crust. So all we got to do to get to 270 is take where we've been, 180 degrees, add the extra crust, pi over 2 to it. Then it turns into a fraction problem. Not too bad. We know we got to get common denominators. So we turn this one into 2 pi over 2. And how did we get that? We multiplied top and bottom by 2 over 2. And then we can add 2 pi over 2 plus pi over 2. And effectively at this point, we're just combining like terms. This is the pi's. 2 pi plus pi is 3 pi. Pi over 1 plus pi over 2 is 3 pi over 2s, or 1.5 pi's if you're more into a mixed number fraction person rather than a proper fraction. But let's clear this out. We don't care about that. We just want our radian measured there. And on page 41, our intro to radians. What radians are? The crust, the measure, the piece of the circumference around the circle, now being kind of combined with our knowledge of basic angles and the circumference of a circle. And that's where we're going to stop for today. So if anyone has any questions, as always, please hit me up, turn in the RLQ, email me. And if not, I look forward to seeing y'all on Thursday, okay? On that note, see ya. I appreciate y'all being here as always.
Bye.
Bye. Have a great rest of your day and a fantastic Wednesday.
You too.
Thank you.